Okay, here we go with concept 1, roots and radicals. On number 1, we're asked to simplify the radical 18 times radical 6. In other words, root 18 times root 6. Well, root 18, if we think about this a second, is the same thing as root 3 times root 6. And then I already have a root 6 here. Well, root 6 times root 6 is just plain old 6. So that's nice and easy. And root 3 will not simplify. It's as simple as it gets. So number 1 is 6 root 3. That's as far as we can take that in its simple radical form. Number 2, we've got a pretty good size number in there, 625. We need to find the fourth root of that. So when I see a problem like this, I basically see chunks. I'm doing the fourth root of 625. I'm also doing the fourth root of x to the 20, and I'm doing the fourth root of y to the 16. So the fourth root of 625, well, if I get a little calculator help, or if I work with this long enough, I'll find out that's 5. 5 times 5 times 5 times 5 is 625. And you may remember that 25 squared is 625. So that'll give us 5. When I'm doing the fourth root of 20, I ask myself, how many times does 4 go into 20 evenly? The answer is 5. So that means I will get an x to the 5th out of the radical. When I do the fourth root of y to the 16, I ask myself, how many times does 4 go into 16? Well, the answer is 4. I get a 4, y to the 4, out of the radical. There we are. We've got 5, x to the 5th, y to the 4th. And we're done. Number 3, similarly, we can split this up and look at the chunks here. I've got 3. Let's see. I'll do that down here. I've got the cube root of 24 times the cube root of a to the 16 times the cube root of b to the 15. Now let's just deal with the separate parts here real quick. The cube root of 24, well, there isn't a perfect, that's not a perfect cube, so I've got to break it apart. I know that 24 I can get what? 1 and 24, 2 and 12, 3 and 8. 3 and 8 is a good choice because the cube root of 8 is 2. That's a perfect cube. So 24 is the same as 8 times 3. So we'll start there with the 24 times. When I'm doing the variables here, I ask myself, how many times does 3 go into 16 evenly? Well, that goes in there 5 times, so I'll get an a to the 5th out, just like I was getting the x's and the y's up here. But there's 1 left over. When I divide 3 into 16, it goes in 5 times with 1 left over. That 1 left over leaves me 1a inside. Times, how many times does 3 go into 15, or 3 into, I didn't write the 15, 3 into 15, that goes 5 times. So that's just b to the 5th with none left over, so I don't leave anything inside. I know the cube root of 8 is 2, so I'm going to make that simplification right here, and I'll just write down everything I have on the outside is a 2, and a to the 5th, and a b to the 5th, and everything I have left inside is a 3 and an a. So there's my simplified number 3. 2a to the 5th, b to the 5th, cube root of 3a. It's breaking down each chunk at a time. Number 4, let's switch colors here so we don't combine in with that. The cube root of 108 divided by the cube root of 2 should be the cube root of 54. 108 divided by 2 is 54. Since they're both under cube roots, we can go ahead and combine with division. 54 is not a perfect cube, but it has perfect cube factor of 27. Cube root of 54 is cube root of 27 times the cube root of 2. The cube root of 27 is 3, and the cube root of 2 will not simplify. So we're simplified down to 3 cube root 2. That's numbers 1, 2, 3, and 4. Number 5 and 6, dealing with some binomials. Actually, that's not a binomial, but we're dealing with radical expressions. Number 5, we've got the fourth root of 6x and the fourth root of 6x. Those are like terms. We can go ahead and add those together. If I take 4 of these things plus 4 of these things, that'll give me 8 of these things. What are these things? These are fourth roots of 6x. The fourth root of 6 doesn't break down. The fourth root of x doesn't break down. So we are as simple as we can get right there. On number 6, I need to know that the square root of 16 is 4. So that is just a 4 right there. and I can go to work. 2 times 4 is 8. I have negative 1 root 6 minus another 6 root 6. That's minus 7 root 6. And that's all I can do on number 6. That's numbers 5 and 6. Number 7, we're asked to multiply. So let's go ahead and FOIL or distribute however you think of this. It doesn't really matter as long as you pick a valid way to do that. I've got 6 times negative 5 is negative 30. 6 times root 2 is 6 root 2. Negative root 2 times negative 5 is positive 5 root 2. And finally, a negative times a positive root 2. Root 2 times root 2. Let's see, that's negative. Root 2 times root 2 is 2. And just find like terms. Negative 30 and negative 2 is negative 32. 6 root 2's and 5 more root 2's is 11 root 2. And that's number 7. Number 8, we're asked to square. But remember, when we're asked to square, we're actually asked to take that thing, negative 5 minus root 7, times itself, negative 5 minus root 7. That's what squaring means. It doesn't just mean square that thing, and write it down. That's not going to work with addition and subtraction, with binomials here. We have to actually multiply the number times itself. So let's go ahead and follow this through. Negative 5 times negative 5 is 25. And negative 5 times negative root 7 is positive 5 root 7. A negative root 7 times a negative 5 is a positive 5 root 7, another one of those. And a negative root 7 times a negative root 7 is positive 7. Find the like terms. 25 and 7 is 32. I've got 5 root 7's and 5 more root 7's. That's a total of 10 root 7's, and there we go. That's numbers 7 and 8. Concept 3, rational exponents. On number 9, I'm taking 14 to the half times 14 to the half. There's a couple ways to do that. I can just add the powers together and get 14 to the 1, or I can think of it as root 14 times root 14, which is still 14. So either way, we get 14. Number 10, let's work this one out here. I've got 8 and 8 to the negative 9 raised to the negative 4/3. So let's split that. 8 to the negative 4/3 times 8 to the negative 9 to the negative 4/3. 8 to the negative 4/3 is the same as 1 over 8 to the positive 4/3. We're not going to want to stop there because we want to get to simplest form. Times a to the negative 9 to the negative 4/3. Well, negative, when you raise a power to a power, that's the only time we get to multiply the powers. So I've got this power raised to the negative 4/3 power. I get to multiply those powers. So I keep my base a, and I multiply the powers. Negative times a negative is a positive. Good. 9 times 4/3. Well, 3 goes into 9 3 times, and 3 times 4 is 12. So that's going to give me 8 to the 12. Now if I can just figure out what this 8 to the 4/3 is, I'm good to go. Well, the cube root of the 8 is 2, and 2 to the 4th is 16. So that's actually 1 over 16 times a to the 12th. 1 over 16 times a to the 12th, which I would probably write as a to the 12th over 16, and be done. Number 11. The thing that gets most people about number 11 is that this 9/2 is only attached to the x. It's not attached to the 9. So the 9's not going to change. We got to leave the 9 alone. Leave the 9 alone. This says we're doing a square root of x. So let's do a square root of x, and x is being raised to the 9th power. So that 9 stays outside. The 9/2 does not get to it. It's like we're saying 9 times, and we are saying this, x to the 9/2. The 9/2 is not touching the 9, so leave it alone. The 9/2 only works on the x. It says take a square root of x and raise it to the 9th power, which is what we've done. So we're good right here. That's number 11. Number 12, we've got 8 to the 2/3 power, so we're going to take the cube root of 8, which is 2, and raise that answer to the 2nd power, which is 4. So 8 to the 2/3 is 4. That's numbers 9, 10, 11, and 12. Let's solve some radical equations. I want to get this root thing by itself. Once I get it by itself, I want to deal with the root. So to get it by itself, we're going to add 2 to both sides, which is going to give me the square root of x minus 8 is equal to 5. Once I'm here, I want to square both sides. Squaring both sides is going to get rid of that radical, which is what I want to happen here along the way. So x minus 8, anything square rooted then squared, those are inverse operations. They'll undo each other. They're just gone. I get what's inside the x minus 8 is equal to 5 squared or 25. If I add 8 to both sides, I get 33. So for number 13, I'm getting 33. If I plug that in, 33 minus 8 is 25. Root 25 is 5 minus 2 is 3. That checks. So this is right. It can't be wrong. Let's do number 14. Let's take number 14 over here. I've got x plus 6 to the 2/3 power, and that equals 9. I've got to get rid of this 2/3 power. The only way to do that is to raise that to another power. The power I'm going to raise it to is the 3/2. If I do it on one side, I have to do it on the other side. So I raise this to 3/2. Why to 3/2? Well, 2/3 times 3/2 is 1. And that's what I want. I want this just to the 1 power, or x plus 6 equals, let's see, 9 to the 3/2. Take the square root of the 9, I get 3. 3 cubed is 27. If I subtract the 6 from both sides, I get 21. Let's check that. 21 plus 6 is 27 to the 2/3. The cube root of 27 is 3, squared is 9. That checks. This has to be right. It can't be wrong. Let's head down to number 15. Actually, number 15, we're going to need some space. So let's do it last and go do number 16. Number 16, can you see we've got both of these things raised to the 1/4 power. So if I just raise both things to the 4 power on both sides, that's going to clear out those powers, and I'll just get negative 6x plus 8 is equal to 4 minus 10x. That looks so much simpler than what we had down below here. Let's add 10x to both sides. That'll give me 4x plus 8 is equal to 4. Subtract the 8. 4x is equal to negative 4, and divide by 4x is equal to negative 1. If we plug that in, it will check. I'll leave that check for you. That's numbers 13, 14, and 16. We'll do 15 next. Okay, number 15. We've created some room on the paper here, so we have room to actually do this one. The radical's already isolated, so we'll go ahead and square both sides. If I square the left side, I get rid of the radical. That's what I want to happen, so I'm going to do the same thing. I'm going to square the whole left side. If I square the right side, I get rid of the radical. Squaring this side, I get 36x. Make sure you square the 6 and the x. X squared. Let's square the 6 and the x. If we square the right side, I get 20 plus 6x. This sure looks quadratic. I've got an x squared and an x, so let's set it up in quadratic form. 36x squared minus 6x is minus 20 equals 0. Well, I noticed that I've got even numbers everywhere here, so I can make things a little simpler by dividing everything by 2. So let's do that. Divide both sides by 2. That gives me 18x's squared minus 3x's minus 10 is equal to 0. Now I've got to try to find factors for this thing. And the method we've been working with is the AC, what we call the AC box method. So if I find A times C, that's 18 times negative 10, that's negative 180. And identify B, that's negative 3. Now I'm down to the difficult task of trying to find two numbers that multiply to make negative 180, but add up to negative 3. After some work, I found the two numbers to be negative 15 and positive 12. Negative 15 times 12 is negative 180, and they add up to negative 3. So here we go. Let's create the box and solve this thing. So again, we call this the AC box method. It's kind of pieces of other methods that we picked up and kind of made our own a little bit. So I've got my first term is 18x squared. We'll put that in the first box. My last term is negative 10. We'll put that in the last box. My middle term, my negative 3x, gets split by a negative 15 and a positive 12. So negative 3x is the sum of negative 15x and positive 12x. And again, it doesn't matter which of these values goes in which box. This all works out. If I put the 12x here and the negative 15x there, it doesn't really matter. Now we're going to look down this column and ask ourselves, what can we factor out of an 18 and a negative 15? We'll always take out positives here in this first step. I can take out a 3. What can I take out of an x squared and an x? I can take out an x. Now, 3x times what is 18x squared? Well, I need 3 times 6, and I need the x times x to get the x squared. So 3x times 6x will give me the 18x squared. Then 3x times what is negative 15x? Well, that's negative 5. 6x times what is 12x? That's 2. And notice that 2 times negative 5 does give me this negative 10. So my factors here are 3x plus 2. No, it's a positive here, even though we don't see a plus. And 6x minus 5. That equals 0. So x could be negative 2/3 or 5/6. We need to check both of these answers. Negative 2/3 will not check. I think you'll see when you plug that in, you get a negative value here and a square root there. There's no way a square root can equal a negative value, so we're going to reject that guy and keep the 5/6, which does check. I'll leave that check for you. That's number 15. Okay, number 17. You guys are getting pretty good at this stuff. We're taking f of x plus g of x. Well, if I just need to find the f function, which is negative 3x plus 4, find the g function, which is 5x minus 6, and add them together. If I add negative 3 and positive 5x's, I get 2x's. If I add 4 and negative 6, I get minus 2. So there's my solution for f of x plus g of x. Just combine those together. Number 18 asks us to find f of g of 2. I prefer this notation to that notation. They mean exactly the same thing. You would do exactly the same thing to solve. So what we're going to do here is we're going to find g of 2. So go to the g function, find it, it's right here. Put 2 in for x and see what you get. Well, negative 4 times 2 is negative 8. Plus 2 is negative 6. So I've got f of negative 6. G of 2 is exactly the same as negative 6. And so this is asking me now to go find f of negative 6. So go find the f function. It's right here. Put negative 6 in for x. Negative 3 times negative 6 is positive 18. Minus 6 is 12. So f of g of 2 is 12. And that's numbers 17 and 18.